All right, so let's take a look at some other ways of representing data, structuring data. In particular, let's look at inheritance and generalizations. So this is the data model that we looked at earlier. We had said that we would have a top-level representation of users and different types of users, where we have faculty and students that they might share most of their fields, but certainly we might have something that is specific to each one of them. Unfortunately, generalization is not supported by MongoDB or by JSON in any way. So what we'll need to do is use a strategy that we already used in relational databases. Relational databases don't support generalization either, right? So we have the same kinds of constraints and options that we have when we are implementing something like this, right? So we're going to be using a technique that that some of you already used in the JPA assignment, where you were asked to do some generalization. We're going to be using the single document or the single table strategy, right? Where we're going to have one collection being able to represent multiple types of objects, right? All driven by a discriminating field, right? So that we can know which one is what actual value are we referring to, which different type are we referring to. So, for instance, in the same user collection, we're going to use the same user collection to represent both faculty and students, right? And we're going to use an additional field called the type field, which will tell us whether this is a faculty or a student. Okay, and now some of the fields won't make sense if you're a faculty, and some other fields won't make sense if you're a student. Right? For instance, now in a relational database, this is a big deal, right? Because if you use a single table implementation in a relational database, right? And I think we used it for widgets, right? And if you use the single table implementation, the D type, the discriminating field, told you which, for a particular record, what was the actual object that was used to instantiate that particular record. Yes, and so only the fields that made sense for that particular data type had actual values. Right, all the others were null. Okay, and DBAs kind of cringe when they see a database or a table that has tons of this null everywhere, right? Folks look at this and say they cringe. But in this particular instance of using generalization, implementing generalization, is perfectly acceptable, right? It has a particular reason why it's like that, right? We're using it to be able to then instantiate the correct data type, right? And D type tells you whether this set of fields or those set of fields or those set of fields, which one matter and which one should be ignored. Yes? Now, in a non-relational database, it's not as important. It's not as cringe-worthy, right? Because there's no such thing as things being null, right? Because in Mongo, there is no schema. If the field's not there, I don't have a value. It's just not present, right? So if I store for faculty, information about faculty such as office, and for students I store GPA, that's totally fine. GPA won't show for faculties, and offices that won't show for students. Right? There won't be this null everywhere that would otherwise be found in relational databases. All right, so we had Ada. We had created Ada. We're going to update Ada, and we're going to say that Ada is now a faculty. Notice that we have db.user.find. Right, we still have here Ada, Poe, and Tim. Let me remove Poe here. Let's say db.user.remove, and I'll remove the user usrnm equal to Poe. So if I find that right now I only have Ada and I only have Tim. Excellent. So we're going to make Ada a faculty. So we're going to update the whoever's username Ada is. We're going to set the type equal to faculty and office equal to 132A. If we do a find again, we'll notice that Ada now has an office and she's a faculty. Okay. Let's do something similar for Tim. Actually, no. Let's insert a couple folks here. We'll insert John here and into the user. And John now is going to be a student that has a GPA. Right? So we find here we have one faculty, one student, and we don't know what Tim is. Okay. Notice that in this case, you know, Ada has no GPA and John doesn't have an office, which is fine, right? We're going to drive the type through when we instantiate them on the server or when we instantiate it on the client, we can drive that logic by the type. Okay, let's insert a couple more students. There's Jane, which doesn't have a GPA, and then we're gonna we inserted Jane. We inserted Jane, and we can update Jane by using an update, and now we have all the students having a GPA. Everybody good? All right, awesome. We can now retrieve all the students, right? Or we can retrieve all the faculty as Ada. All right, awesome. So we know how to capture or data model inheritance.